are entitled to the certificates. Lastly, if you missed or failed a course, you will not get a micro-specialization pathway certificate, but you will get individual course certificates. Please give us a thumbs up if the guidelines are clear for everyone. All right, thank you. Thank you, Spartans. To resume our discussion on experimentation, let us welcome back our SMEs, Ms. Jane Liza Domingo and Sir Jerby Lopez. Good afternoon, ma'am and sir. But I think, I think we'll resume Sir Jerby's discussion from yesterday. Sir Jerby, take the floor.
Ayan. Good afternoon, everyone. Can everyone hear me? Ayan. So, sige. We will be continuing what we started yesterday in the completely randomized design module. Sige. Let me share my screen again. Ayan, so can you see my screen now? So yan, so yesterday we stopped at the model adequacy checking and we're done with the normal probability plot. Now, sige, let's just recall for this topic. So we did an analysis of variance for data. For our data, we have one factor. So we are interested in checking the factor, the power setting. So just to recall, in a completely randomized design, so here it's the power setting. So what we are interested in finding kung may effect ba yung power settings sa H rate. So we found out through the ANOVA or analysis of variance na meron silang significant difference sa means nung bawat treatment natin by looking at the p-value and as well as yung sa F, kung kayo sa F, statistics and the table value. Ayan. So that's the analysis of variance results, may significant difference. And now we moved on to the model adequacy checking. So we're done with the first one. Ayan. So for this, we found out that wala naman siyang major deviations from the normal distribution by looking at the normal probability plot. Using the quantile or the percentile rank of the residuals. And we also check this using the R function for analysis of variance and then doing the QQ norm for the normal probability. Now we move on for the checking for. So I hope everything is clear on this first part. Now we move on to the residual plot versus the fitted values. So dito, chine-check natin kung constant ba yung variance. Gusto kasi natin na yung error term natin ay equal yung variance nila. Ibig sabihin, hindi siya nagva-vary depending on some factors. Like for example, sometimes yung residual plot natin, minsan yung plots nila may pattern. We don't want that. Gusto natin all throughout constant yung variance. So we do that by plotting the fitted values versus residuals. So we just get the fitted value from here. So let's recall, yung fitted value, that's just the difference between the observed value and the fitted value. Actually, that's your treatment means. Okay, so yun, and then natin. So let's get the fitted value. Wait, I think, I have, siglit lang ha. I think I'm using, the wrong file. Let me, sorry. Just a moment. Ayan. Yeah, sorry for that. So let's continue. So we get the fitted value. Okay, so we plot here and then also get the residuals. So straightforward lang to next scatter plot. Ayan. So let's get the scatter plot of the fitted residual, fitted value versus residuals. Ayan, so we have the residual plot with fitted values and the residuals. So here, let's to make the plots more pronounced, let's just adjust again the minimum. So yan, so yung gusto natin dito is that ano siya, equally distributed sa ibabaw ng zero sa ilalim. And gusto din natin walang defined pattern. Sometimes kasi ano to, sometimes minsan ano to, minsan dun sa left part medyo dikit-dikit sila and then pataas, parang nagiging ano siya, funnel shape. So we don't want that. And hindi rin natin gusto na parang ano siya, yung frowning, yung parang naka-U or naka-inverted U. So gusto natin ganito, just parang randomly distributed siya. Walang specific pattern. So with this, we can see na yung residuals, constant yung variance niya. Ayan. So in statistics, we call that homoscedastic. Ayan. Now for the next one, so it means we already satisfied the normality assumption ng error term. And yung homoscedasticity or constant variance of the residuals or the error terms. Ayan, sige. Now last one. Ayan, last one. So this one, we want to check yung independence ng residuals. So we want to see kung may effect ba yung pagkakasunod-sunod ng runs. Kasi minsan yan, kapag halimbawa, iba yung mga experiment, we have runs, yung first run, second run, until the last run. So we don't want na may effect siya, yung pagkakasunod-sunod niya, doon sa residuals. So gusto natin independent sila. So we do that, so by using the run order, So we have here the run order. So ano na to, when you run the experiment, dapat ano to, this is obtained through the randomization. Diba? When you design the experiment, kailangan randomize. That's why we call the experiment completely randomized design. Kasi naka-random order yung run. So ito yun. So the run order, this is done either by a computer or through paper like drawing lots. So there are many ways that you can randomize. So you can just, again, plot here the run order. Versus residuals. So we do again the scatter plot for this. Ayan, so ito yun. So again, same as the fitted values versus residuals. Walang defined pattern, di ba? Parang random lang siya. So nasa gitna yung 0, and then may mga points sa taas, may points sa baba. And seems like random yung kaniyang pagkaka-plot. The rank order is pre-assigned na po ba? Ayun, that's a good question again. So the rank order is determined before the experiment. So that's the part of designing the experiment, the randomization. Yeah. So sa planning pa lang ng experiment, nandun na siya. Okay, so I hope that answers the question. Ayun. So, ayun. Let's, you get that through the randomization sa planning, yung run order. So yan, so with this residual plots, we can see na okay yung model natin, walang issue sa residuals using the normal probability plot. So constant yung ating, normal yung distribution ng residuals and constant din yung variance. Yan, ng residuals. Also, walang effect yung pagkakasunod ng runs. So, ibig sabihin, we can already use the results of the analysis of variance. We can see that, there's at least one pair of treatments with significant difference. So, yan. So, you can see here the means, di ba? 551, 587, 625, 707. Though, you cannot say for now kung sino dyan yung different kasi you need to do post-hoc analysis. So that's done using multiple comparisons test. So kung sa SPSS, maraming options yon, i-click mo lang. Yan. Though may mga methods din like confidence interval methods, but yeah, that's for another sessions. Homework. Ayan, but yeah. But based on the observation, we can see naman na kung alin yung mga means na mataas, mababa. But that's the next step, multiple comparisons. Ayan. May question ba tayo sa model adequacy checking sa Excel? So I just want to emphasize again, when you run analysis, hindi ka nag-e-end sa kita mo yung p-value. So it's either significant or not. So you don't stop there. So you still have to check kung yung model adequacy niya, kung may na-violate ba na assumptions or not. Kasi we have assumptions for the analysis of variance. So kung hindi siya na-satisfy, you can do transformations sa data mo. That's an option. And also sometimes, pag talaga hindi kaya, minsan pinaka-last option is you can do some like non-parametric tests, like Proskal-Wallis test. So another option yun. But yeah, I think mostly naman, okay sa analysis of variance. First, robust naman din ang analysis of variance sa violations of normality. So, yun. Basta hindi siya ganun ka sobrang obvious na hindi normal. So, yun. Ayan. So, now, quickly lang, let's continue yung yesterday, yung kung paano siya gawin sa R. Let's see. Quickly lang. Mabilis lang naman to. Sige. But before we move there, may questions ba? Side comment pala, I've worked as a freelance statistician for college students and master students. And isa yung analysis of variance, pinaka-common analysis and t-test. May mga konti na more advanced like logistic regression and yung mga non-parametric. So medyo siya, talagang medyo kung naintindihan nyo to and you have research on your own, mostly with the knowledge and analysis of variance, medyo kaya mo nang gawin yung research mo mismo with sa Excel lang din. So may question about sa Likert scale, treated as ordinal po yun, sir. Kapag isang item lang siya and you have 1 to 5, strongly disagree up to strongly agree, that's Likert item. So that's ordinal. Okay, kapag isang item lang. Now, if you use a Likert scale means marami kang items na Likert and you use summative or you add the scores in each item or you average them, you can already treat it as interval data. So as long as or you sum it, you can treat it as interval data and you can do analysis of variance on that. But if it's just single item, ordinal yun, hindi siya pwede sa analysis of variance. I hope that's clear. That's also one of the major misunderstanding sa Likert items. So we have Likert item, so yun yung isang item lang. And when it's a Likert scale, scale, maraming items yun, and you average it or you add the scores in each item. Okay, so kapag maraming items and you average it, you can use the analysis of variance on that. Ayan, kasi interval na siya. Ayan, so sige, let's move quickly to the how to do it in R. So maybe yung some of you are not familiar with R or iba naman familiar na, but it's a good thing to know na may other options other than Excel. So let's see. Can you see the screen? Ayan, sige. Quickly lang, let's run again the data. Sige, let's run until where did we stop? Sige, let's run it some parts all at once. Ayan, that's your data. And then you do the analysis of variance. So analysis of variance in Excel in R is AOV. And so that's the result yesterday. Then we get the residuals. So you just use residuals function and assign it to variable residuals. And so we're done with the QQ norm or the QQ plot. Okay, let's get the fitted values. So the fitted again is just the difference between observed and the fitted values. Fitted values, this is the treatment means. So now we have now let's get this is the fitted versus residuals. Ayan, so ito on the right. Ito na siya. So again, yan. So you can see randomly distributed yung residuals versus fitted values. Walang pattern and yun, naka-center siya sa 0. Ayan. So that's for fitted versus residuals for the constancy of variance. And then lastly, this is a time sequence. This is the run order. So let's just control enter. So ito yung run order to check for kung may effect ba yung run order nung natin, yung mga observations. And then we plot. So this is residuals versus time order. Yung pagkakasunod-sunod. Control L. Ayan, ito ulit siya sa right. So yan. So same. Yan. Same. Ito rin yung nakuha natin sa Excel. And we can see na, yun nga. Walang pattern. So nakaano lang siya, randomly scattered. So yan. So that's how you do the model adequacy checking in R. So yan. May question po ba dito? So dito tayo mag-end for the model adequacy checking. So for all the design, same process lang. You get the residuals and you check for normality, you check for constancy of variance, and you check for independence or yung time order kung may effect pa. So gusto mo, walang obvious pattern yung scatter plots natin doon. Yun. So kung may obvious pattern, you will have to do some transformation. Ayan. So yun, that's another topic. But this is the basic of model adequacy checking. So may question po ba dito? So we can say that indeed we have significant difference, or we have at least one pair of means that are significantly different to each other. And yun. So meron. So parang wala namang questions. Sige. Yan, I think I can turn you over to later on kung may questions kayo. Maybe if we still have time, we can accommodate some questions. But right now, I will turn you over to Miss Jane to continue the discussion for the course. Thanks, everyone.
Thank you, Jerby. That was a really great discussion. And thank you so much for providing the steps on how to perform ANOVA and check the models. That will be really helpful because I don't think that's highly discussed. No, in my experience, usually sa mga classes, pag nasa regression na, hindi madalas inaabot yung parts na yon kasi nasa dulo siya ng if you're taking classes mo. And so that was a really good opportunity for you to see it firsthand how it's being done. And I'll just share the screen and slideshow. Hi again, good afternoon. Thank you so much for being present today. I hope we didn't burn you out from yesterday's overload of information. But so far, naman, I think you were quite happy, with the lessons that you learned. I hope it's going to be the same today. So we are going to be continuing on experimental design and analysis, but then we'll be on module 3. So today I'll be discussing overviews of randomized block design and the fractional design and how it looks like to analyze the data for these. And these are actually very complicated topics, complex topics. So I'll try as much as I can to be able to deliver this to you in a way that, alam niyo yun, you will have enough information so that by the time you take on like a full-blown course, it's going to be easier for you to navigate the topics because you have the big picture already. Okay, so the randomized block design, we use this to one, eliminate or reduce the possibility of confounding experiments. This is just a recall of what we discussed yesterday, and that could render the experiment practically useless. Because if you don't randomize and if you have confounding effects that you are not able to consider, you may be able to go through all of your experiments and still get invalid results. So this is very important to control this beforehand, because once you have gathered your data already, you have did all of the steps in the actual conduct of your experiment, there's no way for you to mitigate this. So when past those stages, kaya again, very important to control confounding effects. And why do we block in DOE? So it is used to reduce naman or eliminate the variability transmitted from nuisance factors. So speaking of nuisance factors, what are these? So these ones are factors, diba? We have input factors, we have controllable, we have uncontrollable, and these factors will affect whatever the outcome ng experiment mo. However, you're not really interested kung ano yung effect niya dun sa response. And so if, in the case na these factors, they appear as often as your experimental units, the number of treatments, later on, you will learn that these are called blocking factors. So input factors, we have nuisance factors, and then later on, we will classify what a blocking factor is. And then, ayan, there's no denying, when you're doing your experiment, hindi ka pwedeng dumaan sa denial stage na my experiment is so perfect, wala akong nuisance factors, because that's gonna be impossible. You will encounter talaga nuisance factors. So very important for you to determine what these are, recognize them, and then control them. Controlling them is one of our goals here. That's why we're learning the randomized block design. And the experimenter, ayan, you have to really spend time deciding alin sa mga nuisance factors ang important enough. Kasi, if you chase too many, if you're chasing too many things here na gusto mo i-control every nuisance factor that is present in your study, baka naman hindi na siya practical. So you have to balance practicality and, also reducing the variability in your experiment. And okay, this is what I mentioned. So when do we say that a nuisance factor is also a blocking factor? If it appears as much as often as your treatments. For example, you are conducting an experiment on the three fertilizers ulit from yesterday. And ngayon, you hired, for example, this will go on like let's say in a long period of time, and then madami kang experimental units, and one person cannot do it alone, so you have to get another person to help. Actually, yung mga researchers, they also hire research assistants. And for example, this research assistants, for example, if it's an agricultural study, ito yung make sure na water yung plant, na measure yung leaves or stalk on a daily basis. So they hire multiple people at some time. But then again, the number of retreatments present bawat isa doon, yung mismong nagkakandak ng experiment, yung experimenter, yung research assistant. And hence, the research assistant, not that they're nuisance in real life, but in the context of the experiment, they could be a nuisance factor. So you will have to control that. And how do we deal with it? We use this technique called blocking. So by definition, diba kanina, blocking, it removes the variability from caused by these factors, undesirable factors. And the basic concept here is we want to create blocks which are in which the nuisance factors are held constant and the factors of interest is allowed to vary. So magagawa ka ng blocks for each block, iko-constant mo yung factor doon. And then, yung input factor na gusto mo, yun yung ito-change mo. A very, very common example or a very easy to understand example would be yung may question yesterday, controlled group and controlled group in education, I think, if I remember correctly. So when you have a controlled group and you have an uncontrolled group, that's also blocking. So dun sa isang block, i-constant mo kung ano man yung gusto mong i-control, and then sa kabilang block, maiko-constant ka rin doon, but the factor is a different level. For example, schedule ng class. May effect ba sa learning ng mga bata on a specific topic yung schedule ng class? So, yung isang block, 7 a.m. to 8 a.m., yung another block, 8 a.m. to 9 a.m. So, those are two blocks. So, sa isang block, constant, no? Sa lahat ng students na nandun sa first block, constant na yung duration or yung schedule ng class nila, 7 to 8. And then sa isang block, constant naman yung duration ng class nila. And yung period from 8 to 9. And then yung nagba-vary na lang doon, it was how the students are gonna receive the instruction, given that the same teacher is gonna be delivering the same topic. And this is a really general statement here. You have to remember to block what you can and randomize what you cannot in terms of nuisance factors. Okay? Hindi lahat ng nuisance factors are blocking factors, right? So, kung hindi man siya blocking factor and you cannot block it, i-randomize mo siya. So, from our example yesterday, pero I'm just gonna give it a twist. So, problem statement. Does soil moisture affect the yield of the Pag-asa 1 variety of mung beans? This is the problem. And now our objective will be to determine whether soil moisture affect the yield in terms of weight of the Pag-asa 1 mung beans. So our response variable here, obviously, is going to be the weight of the beans. Kasi usually naman yung weight, yung yield in agriculture is measured in weight talaga, tons. That's how we measure the yield usually. Tons per hectare, ganun. But, oops, okay. Now, here are controllable input factors will be the soil type, the soil moisture, or the water concentration, and then we have the uncontrollable input factors, temperature, amount of sunlight, soil minerals, and their levels. Although here I want to focus on just one soil type, just to remove the variability. So I just want to make sure na the type of sand or the type of soil will not contribute, will not have any contribution to the yield of the mung beans dun sa bunga ng mga munggo na itatanim. So I want to focus on that, on the sandy soil. And then for the soil moisture, as I want to use 10, 20, 30, 40, 50%. And because mali yung animation ko, so could you identify some nuisance factors in this research experiment? Ito talaga yung tanong. I was hoping to ask you this. So here I identified one. It's going to be the measuring tool. Measuring tool, for example, maybe yung pag-weigh ng output ng beans. But here I want to focus on the tool that's being used to measure the soil moisture. So it's called a hygrometer. So dito, the experiment is being conducted. Of course, they pour water, diba? And then they have to measure if they have the exact soil moisture that's indicated in the design. So if a unit, yung isang munggo plant, ang naka-assign sa kanya ay 10% na soil moisture, they water it and then they have to measure na yung soil moisture niya ay 10%. And they use hygrometer to do that. So now, I want to make sure that yung hygrometer does not, the type of hygrometer I use will not affect the response, the output of yung bunga ng mga munggo. Kasi baka mamaya may hygrometer pala na hindi masyadong calibrated ng maayos, or baka may faulty sa kanila. So we want to make sure that the tool we are using are consistent, or they do not affect the output. Response variable Y here, which is the weight of the beans. So suppose this is our data, no? We gathered na. So for unit 1, sa Simunggo number 1, we have 65 grams of munggo na na-harvest. And then ginamit natin throughout the study si hygrometer A. And then si experimental unit, another experimental unit here, we set this to 10% pa rin na soil moisture, and then we were using hygrometer B to measure its soil moisture. And in this case, our factors here are soil moisture and hygrometer. So we have 2, and hygrometer here is the blocking factor. Okay, and now we are going to test the following hypothesis at 0.05 alpha. So first, there are no significant differences among the 5 treatment means, and then there are no significant differences among the 4 block means. So yung blocks natin dito, the first one, when we used hygrometer A, the second block is when we used hygrometer B, and then C, and then D. Oops. Okay. And so how do we analyze the data? It's actually similar lang din. You still use ANOVA, and in using ANOVA for this one, it's just gonna be a little tweak if you use Excel, and I'm gonna show you that. Okay. Saan si Zoom? All right. So I have the data already in Excel, and I have already loaded my analysis tool pack. This is very straightforward, no? So your first column, it should contain the first the blocking factor, and under it are gonna be your blocks. And the columns after that will be the output for each treatment. So yung treatment natin dito, 10% moisture, 20% moisture, 30%, 40%, and 50%. And again, these were measured in grams hypothetically. So what do we do? Now I want to perform ANOVA, analysis of variance. It's weird, no? Can you recall? Yung hypothesis natin, actually, we were hypothesizing on the means. Pero we call this test analysis of variance. But it's just that we're using variance to analyze if there are, or if there is a significant difference in the means of the groups that we are comparing. So I go to data analysis. And this is going to be a 2-factor. Again, what are our factors here in this experiment? Can anyone tell me that? Where's the chat box? I-arrange ko lang to ng maayos. Okay. Anyone can name the factors that we have here? Yes. Hygrometer, or the tool, and the soil moisture. So when we perform ANOVA, we choose ANOVA 2-factor, and we did not replicate here, so we choose without replication. And we select our data. Ito lang, wag mo nang isali yung soil moisture sa taas. And check the label. I think you've heard that already. Check the label. Because if I don't check this, if I don't tick this, it's gonna read the first row as if they're part of the data set talaga. Yung measures natin ng response Y, which was the weight. So if I do that, look at what happens. Okay. Output range there. If I do that, it's gonna cause an error. So don't panic. You just check the label, tick this box here, and it should go there. We have now the results. I'm sure Sir Jerby did a really, I was here, actually, we're in the same room all the time that he was discussing. He did a really great job in discussing this to you. So this is now the result of our two-factor without replication. If you look at this part here, ayan, this one is for the rows. It says it's source of variation. If it's the rows, which are the factors, no? If the factors daw, if the blocks cause variation, our p-value is 0.94. So this is what? Where do we compare this? Kanina, we said we test the hypothesis using a specific significance level. So where do we compare? Alpha, that's correct. And we set our alpha earlier to 0.05, right? So now we compare this, the p-value is really, really high. So ibig sabihin, yung hygrometer actually na ginamit during the whole experimentation did not cause any variation to the response. So malamang tama naman yung well, I don't want to go there, but at this point, we can definitely say it did not cause any variation. And the columns, now the treatments, which is, ano yung treatment natin dito sa experiment na to? The soil moisture. So the treatment here in this experiment is the soil moisture, which we varied. Diba? So those are the treatments. Sa treatments naman, our p-value is 0.001646. What does this imply? Yes. So Robin and Joshua, Paulo, you are all correct. So this means that we are going to reject H null or H sub 0. And yes, we have enough evidence to reject H null. That means definitely the soil moisture of the soil, the moisture level of the soil in which we planted the mung beans had an effect to the yield. So here you were able to establish causation. However, again, Sir Jerby already explained how you need to check your models, diba? So make sure to still go through that, although I'm skipping those parts. And I hope that this is pretty clear to you how to interpret this table here. And I want to know if you have any questions. I think somebody's going to send you the attendance link. So just watch out for that in the comment box. But also I want to ask if at this point they have questions regarding randomized block design. So also I want to add, no, for randomized block design, we have complete, we have incomplete, and what was the other one? Oh, the so randomized complete block design, if you have replications, and then if it's if your blocks, no, if yung bawat block mo, the same number of treatments are done, then you have a balance. And if merong isang block doon na may missing treatment, then you have incomplete block design. So ano lang, just keep it at the back of your head. So in case you encounter a situation like that, don't panic. It's already been encountered, and there have been great minds already who who studied these situations, and they have solutions for that. And feel free to visit any reference. But for the sake of this live session, you really have to limit this discussion so we can tackle as much topics as we can. So I want to move forward to the next one, which is the factorial design. And so in the factorial design, if makarecall niyo pa rin yung discussion yesterday, no? Yung steps in carrying out your experimental design, there was a step na you have to determine the design of your experiment. And then may columns doon, depende sa objective mo, if it's comparative objective, screening ba siya, or response surface objective. There are may suggested na mga designs. And if you go back to that page, you will see na it's consistent naman. If it's two or more independent variables upon a single dependent variable, so yung response variable mo isa lang, pero you have two or more input variables, then it is suggested that you use the factorial design. And then here it actually allows for subtle manipulation if you have a larger number of interdependent variables. Kasi diba possible na yung input variables mo have interactions. So, and then possible din na sila kanila mismo merong dependency. And here, in factorial design, you will be able to play around your experiment design so that you can take that into consideration. And it is also a useful method for streamlining research. And you let the statistical methods highlight any corrections, and despite its limitations. Dito lang, all possible combinations of the levels of the factors are investigated in each replication. So, ang bilis mag-blow up yung size ng experiment mo, yung experimental units mo, kapag marami din yung factors. Kasi nga, each possible combination has to be investigated. If you have n levels of factor A, tapos you have another factor, let's say it's called factor B, and you have k levels, then each replicate will contain n times k treatment combinations. By the way, can anyone give me a factor and its levels? I just want to check if we're still in the same page. Sige, I'll start. Parang TikTok, no? I'll start. So, for example, yung fertilizer, yung factor, yung levels niya, fertilizer A, fertilizer B, fertilizer C. So, meron siyang tatlong levels, si factor A. 2 raised to 3. Later on, we're gonna get there. Pero could anyone give me an example? Name any factor of any experiment that you can think of. And then, what would be its levels? So another factor, no? Let's say in what's a good okay. So let's say yung experiment is on baking cookies. So if the factor is let's say the ingredients, no? Let's say the number of eggs. So when I perform the number of eggs added in a certain measurement, no, ng flour, let's say specific natin, yung flour natin is 5 cups. If I add 1 egg, how will the cookie turn out? If I add 2 eggs, kumusta siya? 3, 4 eggs. So, gusto ko siyang gawin up to 5 eggs. So, yung factor ko doon is the number of eggs that's added into the cookie in the preparation. And then the levels would be 5. 1 egg, 2 eggs, 3 eggs, 4 eggs, 5 eggs. So I hope that gives you a better context or understanding when we say factors and levels are. Yes. So I guess my hunch was medyo tama kasi a lot of students or learners really get lost, no? Kung ano ba yung factors, ano ba yung levels. So yun. Numeracy skills needs major support, anchoring, adapting. So if this is the factor, then you have 3 levels. So needs major support, anchoring, and then adapting. Thank you, Robin. And if you still have other examples, please feel free to send them in the chat, and I will proceed with the discussion. So, example, in practical settings, when is factorial design used? One in social researches, and educational methods while taking into account the influence of some socioeconomic factors. You can use factorial design for that. Another would be in agricultural factorial design to test the effect of variables on the crops. I'm not gonna say more about that kasi parang na-mention ko na yung fertilizer example ko 100 times. An engineer would like to test 3 plate materials for a new battery at 3 temperature levels. So ano dito yung factors natin sa third bullet? An engineer tests 3 plate materials for a new battery at 3 temperature levels. So yung isang factor dito will be the plate material, and then meron siyang 3 levels. Yung material A, material B, material C. And then the second factor is, what is it? Temperature levels. That is correct. So, and how many levels are we considering here? 3. That is correct. Okay, you're getting the hang of this now. And ayan, why do we use factorial design? What are its advantages? Well, first, it is more efficient, than having to do one factor at a time. So, gagawa ka din ng experiments mo, one factor at a time lang siya. That is not as efficient as doing them na lang in a factorial design. Another would be if there are any interactions doon sa inputs mo, input factors mo, hindi mo ma-take yon into account during your analysis. And you will have misleading conclusions. And so it allows the effects of a factor to be estimated at several levels of the other factors. Like, yung temperature, kunyari, yung 3 temperature, pwede mo siyang i-test against plate material A. And then also, lahat ng yung 3 temperature levels na yun, pwede mo rin i-test against plate material B. So, you're able to do that when you use factorial design. And here, ayan, so, full factorial designs in 2 levels. Kasi diba, naalala nyo kapag masyadong madaming levels and masyadong madaming factors, mag-blow up agad yung size na kailangan mo. But here, a common experimental design, here, what we do, we set the levels into 2. We label, these are going to be the high and the low. Kapag high, we label it +1. Kapag low, we label it -1. And then, dito, we will allow all possible high-low combinations of all input factors. And we call this a full factorial design in 2 levels. Marami kang factors, more than 2 possibly, pero bawat isa sa kanila, meron lang 2 levels. So we call that full factorial design in 2 levels. And if that is the case, no, we're just gonna need 2 raised to k runs. Eto yun. So, madetermine mo ilang runs ang kailangan ko. So, syempre, if you do isang no replication, edi ano lang, 2 raised to k lang yan. Kung dalawang replication, edi mag times 2 ka lang ulit dito, no? Kung tatlo, mag times 3 ka. So, for example, meron kang 5 factors, and then, ano to, full factorial design into levels to. So, that's gonna be 2 raised to 5 na experimental units yung kailangan mo, and that's gonna be 35. Isipin mo naman, ngayon, though, kapag more than 5 na siya, so, ilan ang 2 raised to 6? 64. Sobrang bilis lumaki ng size, no? So, you maybe should consider also doing the placket, a fractional factorial design or a placket Berman design. So, yep. So that's how you can approach, if you have an experiment, no? That's how you have choices on how to approach them. Full ka ba or mag-fractional factorial design? So eto, for example, the purpose of this experiment is to determine the effect of machining factors on ceramic strength. And suppose hindi pa nakalagay yung number of observations, no? But we determine now that our response variable would be the mean over 15 replicates of ceramic strength. So here we determine 5 factors. One is table speed, 2 levels lang, slow and fast, and then specified yung speed talaga. Factor 2, down feed rate, 2 levels ulit, slow, fast. Factor 3, 2 levels lang din for wheel grit. And then factor 4, direction, longitudinal or transverse. And then factor 5, batch levels 1, 2. Factors 1, 2, 3, hindi naman kasi kailangan talaga na dalawa lang yan, no? Hindi naman talaga kailangan high-low lang. Kasi these are actually continuous factors. But because yung factors 4 and 5 are, tigda-dalawa lang din, qualitative, and dalawa lang yung levels niya, magiging result nito later on, magiging monotone yung effects na. Kaya, it makes sense na for factors 1 to 3, mag-ano na lang tayo, slow, fast. Huwag na tayong kumuha ng center point. Kunyari, yung mean ng 0.25 meters per second and 1.25 meters per second, kunin mo yung gitna nun, yun yung center point. Pero we're not gonna be using them anymore for this case. So, eto na ngayon. Yung mga negative 1 and 1 kanina, no? Diba, 5 factors. So, this is full factorial design. So, we have 32. So, we have 32 experimental units. Makikita nyo yan hanggang 32. And then, these are the settings here sa speed, rate, grit, direction, batch. So, each combination ng negative 1 and positive 1s dyan, that will be unique. So, wala kang makikitang other combination na puro negative 1 lahat. And for this treatment daw, we measure the strength to be at 680.45. Yung order here is pang ilan siya dun sa runs mo. Kasi hindi mo naman sila magagawa all at the same time, right? Simultaneously. So, may unahin ka, may susunod, and the next. So, for example, ito si Unit 1, pang 17 siya na measure. And ito yung settings niya. And ito yung strength niya. And hanggang 32 yan. So, how do we do a factorial design? How do we analyze data from a factorial design? So, one, again, it's a must, no? You have to look at your data first. You plot it. Although I skipped that earlier, pero again, you should begin with plotting your data first. So we plot our data and we use normal probability plot, box plot, histogram, response versus the run order. And here, we have here the normal QQ plot. So far naman, the data points are nasa along the normal distribution line. When you look at the box plot, ano yung median ng data natin? Kasi 'di ba, ito yung data natin kanina. So, without having to compute, by looking at the box plot, ano yung median ng data natin? Approximate. Okay. I'll give you time to, yes, I'd agree. Mga around 580, 590. Somebody else is saying 580. Of course, it was gonna be better for us, no, if this is better yung scale na nakikita natin. But yes, that's around that, yung median, yeah. And since yung median is leaning nasa right side, so medyo skewed to the right yung data natin neto, no? So it's not really normally distributed. Pero could be approximately normal. Not exactly, of course, wala naman talagang experimental data na exactly perfectly normal, which is also consistent with what we're seeing here. And we have no outliers, no identified outliers in the strengths measured. And dito naman sa histogram, kung titingnan mo, may dalawang lump, no, ng para kang makakita ng dalawang histograms in one histogram. One is centered around 450. Ito yan. The other is centered around mga 650. Yeah, 650. This one. So you just take note of that at this point. Sa data natin, malamang ito yan. Ito yung second part. And then the first part is this one. And then when we look at the run order plot, nothing suspicious or nothing to really take note of. So there probably is no significant time effect. Kasi again, we did not take the measures simultaneously for all the 32 experimental units. Magkasunod sila. Now, we take the box plot for each factor. So, dito yung factor will be the table speed. Yung high, mas wide siya, no? Mas wide yung high. Yung low, mas consistent. Ayan. Mas consistent yung strength when the table speed was set at low, at -1. Pag high naman, mas varied siya and mas skewed din siya to the right. Kapag naman yung feed rate, kapag tinignan natin yung box plot ng feed rate, mas consistent din yung mas consistent, mas normally distributed, mas yung approximating normally distribution, mas malapit sa normal distribution yung low kesa sa high. And dito naman sa wheel grit. Okay. This is it. Okay. Can somebody tell us something? Share to the hindi naman to class, to the session. Okay. How would you read this box plot? The wheel grit. Wala nga lang tong plus points, but I would really appreciate if somebody unmutes and shares how they would interpret this box plot. Wala? Okay, sige. Since naghahabol tayo ng time, maybe naiisip nyo na paano, pero baka nahihiya lang kayo. So this one, tingnan nyo, mas mataas yung mean niya kapag yung wheel grit is set into low versus when it's set to high. So actually, at this point, papaisip ka na, baka mas maganda pag low yung wheel grit nakaset, no? Kasi yung strength, mas strong yung ceramic plates when it's set to low. And yung ano naman, to variability, hindi naman masyado malayo. Dito, ngayon, yun yung sa direction. Ayan, sobrang laki ng difference when you set it to low versus high. Yung maximum value, yung, wait lang, this is, hindi ko nakikita yung cursor. This is median or 50th percentile. This is third quartile. This is around 1.95 times, this is third quartile plus 1.95 times the IQR, interquartile range. Mas malaki pa rin yung lower limit, yung lower value ng low direction. Hindi low to. Longitudinal. Longitudinal versus transverse. So, mas mataas yung strength ng metal plates natin when the machine creating the plates are the directions are set to longitudinal. Strength by batch. Ayan, the variability seems they look similar, no? But mas mataas pa rin overall yung strength ng ceramic plates for batch 1. Okay. Questions? Sorry, I'll just ano lang. Okay, so next. Ayan. Step 1 pa lang yun, no? Medyo mahaba na. Step 2, create the theoretical model for, okay, actually, I want to ask someone to read the left side. Ito, yung nag-react. Sino? Hindi ko makita yung name. Baba ko nga itong Joshua. Oops, nawala yung slide. Nasaan ako? Here, could you read the one on the left? So for a 2 raised to 5 full factorial experiment, we can fit a model containing what? Nag-unmute ba siya? Or are you not ready to unmute?
Good afternoon, everyone.
Yes. Hi.
Step to create the theoretical model for a 2.
Ayan. On the left side, for a 2 raised to 5 full factorial experiment, we can fit a model containing
a mean term, 5 main effect terms, 10 2-factor interaction terms, 10 3-factor interaction terms, 5 4-factor interaction terms, and 5-factor interaction terms.
So that is correct, no? And did someone do the math already? Ilang terms to lahat? Imagine this is an equation and each term, if you can still remember na yung terms, no, sa isang equation, if na-relate nyo pa rin siya doon, did someone do the math? Ilang terms to lahat? We have 1 for the mean, and then 5, so that's our 6, and then 10 and 10, so 26, and then 5, 31, and then another 5, 36. Tama ba yung arithmetic ko? 36, tama. We have 36 terms in this model, in this theoretical model. And I hope that does not overwhelm you at this point yet, but we have ways to approach this in a more practical way, which is 1, we would start with the 3-factor interaction terms muna. So, higher than 3-factor interaction terms, yung x sub 1 times x sub 2 times x sub 3 times x sub 4, tapos meron kang beta 1, 2, 3, 4, diba? Di mo muna sila isasama. Kasi it's very rare to happen na ganun kataas na order and we are gonna get significant results. And then we will allow the assumption will allow us to accumulate yung sum of squares for these terms and use them instead to estimate an error term. So aside sa 36, diba, may error term ka, and then meron ka ding constant term when all the other terms are 0. So meron ka actually 38 lahat. And then we start then with the theoretical model with 26. Kasi 10 na yun, no? Tatanggalin natin tong 5 na 4-factor terms. Tatanggalin muna natin yung 5-factor interaction terms then. Actually, 32 pala to. 5. Yep. So, tatanggalin natin yan. Ang matitira will be 26. And 26 unknown constants. And then we will hope that the data will clarify which of those 26 terms are actually significant, no, doon sa experiment natin. Alin yung main effects, significant na main effects, significant na interactions, and then and ma-identify natin later yung final model natin. So here we fit the model to the data, and our summary of fit, ito yun, R square, and then we have it's 0.99, which is really good, and then R square adjusted. What's the difference between R square and R square adjusted? Does anybody know? Or someone, you can actually take a guess. I'm curious about what you think the difference is. Okay, I know it's Friday. It's already what? 3:30 p.m. So sige, lusot kayo. Ayan, with or without error. Well, that's a really good guess. Thanks, Paulo. Anybody else? Okay. So no, hopefully that steered your minds a bit with the difference ng R square and R square adjusted. Yung R square adjusted is yung R square, pero taking only into consideration yung mga significant na terms. So yung R square naman, kasama pa yung mga not significant na terms. So, kung sa model, kung tatanggalin mo yung hindi significant na terms, your R square adjusted is 0.97 approximately. So this is still really good. And yeah, it looks like you have a good model at this point. Again, you will still have to confirm this with the steps that Sir Jerby gave you. And then mean response, 546. Mean response, yung response natin dito ay ano? Naalala niyo pa yung response variable ng experiment na to? So, I'll give you a pass. I'm gonna scroll back. Yes, that's the strength. So our mean response here is the strength of the ceramic. Ceramic. Oh, ceramic strength. And thanks, Paul. And okay. And then yung observations, tama naman yung account niya, 32. We really had 32. Can it be referred to as margin of error, yung adjusted? This will have, you still have to compute this. Actually, ito yung root mean square of error. Wait nga, let me check. This is 17.82. Yeah. So yung mean square of error mo, actually you square this one. And it's not equal to R square adjusted. I am sure that they have a relationship, but I cannot recall right now on top of my head what the formula is. But short answer is not really, no. Ayan. No worries. Thank you then Anna for asking. All right. So steps in conducting factorial design pa rin tayo. Remember, we considered 26 terms. So yung 26 terms na to, imagine mo na lang yung model mo, x sub 1 plus x sub 2 plus x sub 1 times x sub 2 plus x sub 3 plus x sub 1 times x sub 3. Ganun siya kahaba. And we have 26 of those hanggang sub x3 times x4 times x5. So ito yung terms na consider natin, and we can see, no, at the rightmost column, we can see the probability. So assuming our alpha was at 0.05, any term here with p-value less than 0.05 will be not significant. So ang significant lang dito will be a few. For example, x2. Is it significant or not significant? This one, x2. Does it have effects on the ceramic strength? Yes, it is significant. Thank you. And then let's see, x1 times x2 times x3. Does it have effect on the ceramic strength? No effect, because it's not significant. All right. Great answer. So thank you. And we have more here. And yun, diba, we have yung r squared natin doon was around 0.99, and then yung adjusted r squared natin was around 0.97 or 0.98, so malalaki pa rin. But we still have high number of greater than n. So if we set it to 10%, alpha 0.01, alpha 0.1. So kapag ganon, eto significant pa to. Eto significant, yan. Ang mangyayari doon, marami pa rin terms na matatanggal. So it makes it clear that the model has many unnecessary terms. Wala talaga yung either interaction man yon or main effects. Hindi sila necessary sa model natin. So starting with 26 terms, we can use this. We have this thing called stepwise regression. It's a method. It's a beautiful method, pero it's already regression and we haven't discussed that yet. So I'm just gonna leave this at that muna ngayon, no? There's this thing called stepwise regression, and we can eliminate unnecessary terms. But at this point, we also have limitations, so I cannot show you how it's done exactly. But that's how we can do it, and then we eliminate the terms, and then yung matitirang terms, mag-regress ka ulit, tingnan mo kung meron pa bang significant at not significant, magtanggal ka ulit. So ganun siya. Hanggang ang matitira, yung ano na lang, significant na terms na lang yung matitira. And by a combination, yan, ang matitira daw, 12 significant effect terms. Pero dito, yung ginamit niya na p-value, 0.05, eventually bumalik din siya. Ano lang yun? Pwede mo naman kasi what do you call this? Pwede mo tingnan, pag 0.10, 0.5, ganyan. Although, ideal talaga is you stick to the p-value that you set earlier. Especially the ceramic being manufactured has critical function, no, if it could endanger lives. So very critical talaga that you stick to your p-value. And then 12 na lang daw yung matitira with the 12 significant terms identified in the stepwise regression that unfortunately we cannot show here to you today. Yung r square natin, 0.99, yung r square adjusted 0.98, but they're actually closer. May break ba? Actually, no, hindi pa tayo na-break. So, sige, we'll take a break after a few slides. And yeah, thank you for reminding us. And we're very keen to discussing as much as we can. No, nakalimutan na namin yung break. Or ako lang, baka ako lang yung nakalimot. For sure, the Sparta team here, hindi naman nila nakalimutan yan. And so we're gonna take a break after a few slides. I'm just gonna go through this chunk of topic, and yeah. So yes, yung RMSE natin is lower, and yung R square and R square adjusted actually are closer, which means ano na lang. We could even account for the error term na lang for the R square and R square adjusted difference. Yan. So after all those steps, ito yung matitira na terms. So your model will be, sit here. So yung candidate model natin ngayon, yung candidate model natin will be Y, the ceramic strength is equal to X1, kung ano man yung ano niya, the beta 1 times X1 plus beta 2 times X2, and so on. All of this with their coefficients. And I think this should be enough for now. We can take a break, 10 minutes break. So go get snacks or bio break. I'll see you again in 10 minutes. That's 3:45. Thank you. All right, thank you so much for your patience, no, and I hope you were able to take your breaks really well. So for this factorial design, we're actually almost through, and yeah, and if you have questions, just shoot them in the chat box or in the Q&A box. Okay, there. So now, okay, we found all these terms to be um, we found these terms to be significant, no? They have significant effects to the strength of the ceramic. But still, we haven't tested our model yet. So that's actually what you will have to do. You don't stop at, getting a model and having significant effects and terms. You still have to test it. You have to evaluate your model. So, ano yung ginagawa to evaluate a model? The model, ano yung sabi ni Sir Jerby kanina and yesterday? What do we do once we arrive at this model? At a model. It had something to do with residuals. Could you still recall? What are we gonna do with the residuals? Actually, nakabalik na ba kayo lahat? If nakabalik na kayo, could you let us know by sending us reacts just to make sure. May nag-react ba? Hindi ko actually nakikita. Raised hand, yes, John Hale? Or is that just a react? Was it supposed to be a react lang? Or do you have any question? All right. Arlene, thank you for sending. Yes, actually chat box na lang, no? Mas madali kong makita. Thank you so much. All right, John Hill, I think this is really a question. Yes, please feel free to unmute if you have questions. We can't hear you yet, but if you have questions, I'll just move on for now, just to for the interest of time. But if you have again questions, please feel free to send that in the chat box. And thank you for those who sent us their reacts in the chat box and who use the feature talaga ng reacts. Thank you so much for letting us know you're back. So I continue na. So yes, again, you evaluate your model, you plot your residuals. That's what you're gonna do, and you check if it is normally distributed. But in this case, it wasn't, no? Merong funnel out dito. Habang lumalaki yung predicted strength, yung residuals naman lumalayo din. Habang tumataas yung predicted strength, yung residuals natin lumalayo from 0. So in that case, yeah, so also you inspect, no, baka merong outliers dun sa mga natirang effects na significant. And here, wala. So, but since meron talagang pattern, may pattern yung residuals mo, you really have, when we say that the residuals are normally distributed, wala siyang pattern. Wala kang pattern makikita, unlike this one na nagpa-funnel. And it will warrant, a data transformation. So you transform your data, and then you do it over again. And then, you do it over again until you get a residual plot that's pretty. And by pretty, I mean it's normally distributed. So when that was done, for this example, so the data was transformed, and when that was transformed, we found out that the X4 times X5 interaction is actually not significant. So hindi na siya significant this time. So we will have 11 effect models na lang. And with that, tumaas yung R-square natin, yung R-square adjusted medyo tumaas din. And our RMSE bumaba. And these are good results. Diba kanina pa tayo nakakakuha ng good results, no, sa summary of fit? Pero hindi tayo lang doon nagsistay. If any of you experienced na you modeled and then nag-end lang kayo by when you got a good R-square or R-square adjusted, this okay na, maganda na yung model, that's it. Since now you enrolled and you took this class, you know, so yung conscience niyo will not let you sleep now by ending it there. So you really have to check your model. Yan. And then we have parameter estimates. So ito na yung beta sub-zeros ng model mo, which are all significant naman. And better behaved yung residuals nila, although may possibility pa rin to na meron pa rin terms doon na hindi linear. Kaya, ideally, uulitin mo siya. If wala naman, you still get the same result, then you could stop there. Pero if you're still getting a new set of, say, significant terms, then it warrants further investigation. So you have to do the steps again from the beginning. So eto, I'll get to step 5. So you have to answer the questions in your experimental objectives, no? Kasi yun yung guiding star mo from the beginning. So yung results mo ba ngayon, answer that. Here, the magnitudes of the effect estimates show that direction is by far the most important factor. Paano natin masabi na direction ang most important factor? Because siya yung may pinakamalaking parameter estimate. So sobrang laki ng naaambag. Sobrang laki ng naaambag ng direction. Longitudinal or transverse, sobrang laki ng epekto niya sa resulting or sa produced na ceramic plates. What else? Batch plays the next most critical role, followed by wheel grit, and then several important interactions, and then followed by feed rate. Ayan. So you summarize the results of your experiment and your analysis. So we now plot yung main effects and the significant two-way interactions. I hope you can still see the graphs. Ayan. This is batch transform strength. We did a data transformation, no? I did not really discuss but this is the data transformation that we use, the Box-Cox transformation. This is also commonly used in data transformations, in any study that needs some data transformations. Isa to sa mga go-to, yung mga exponential and yeah, the polynomial transformation. So ito, Box-Cox transformation. So, and then speed. Ayan. So, gano'n ka-layo yung difference ng effects nila. All right. So, I will not stay longer on this topic. I'm sure you are gonna encounter this if you take more experimental design topics and if you delve more on factorial design. There are still available resources. Actually, books pa rin the best on factorial design. I cited some books here in the reference list, so feel free to go over them and see and discover more about factorial design and how you can customize it to fit other situations of your experiment or what your needs na experiment. And the interpretation, no, the mga pink line and blue line is also indicated here. Yeah, and actually, I want to stop here. If you have questions, yeah, I don't think may nagtanong, parang isa lang kanina. Did not catch what to tweak on the next trial from step 1. Does it mean to redo the experiment? Okay, so I think you're asking about kung hindi normally distributed yung residuals mo, tama? And then, yung sabi ko na you have to do it again. Okay. So, hindi maganda yung residuals mo. So, you have to transform your data and then you start fitting it again. So, yung natitirang 12 na effects, you start fitting your model again, no? So, magkakaroon ng bagong estimates dun sa parameters and magkakaroon ng bagong F-tests for the significance of their effects on the response variable na ceramic strength. So, yun, magsisimula ka ulit dun. Mag-model fit ka ng data, pero hindi ka na magsisimula dun sa sobrang dami. So, dun na lang sa 12 na natitira. So, mag-model fit ka, and then, identify mo yung significant, not significant, mag-plot ka ulit ng residuals, and that. Thank you. Thank you, Oswell, for asking. Any other questions? Okay, I guess there's none. Thank you so much for listening. I'm gonna turn you over again to Sir Jerby. Thank you.
Thank you very much, Miss Jane, for that thorough discussions on randomized complete block design and factorial design. So, okay pa ba kayo? So, yan. So, we're done with the first 3 types of design. So, the first one, we have the completely randomized design. And then, a while ago, we had a randomized complete block design. And also the last one, factorial design. So, now, I think, so meron na kayong overview ng mga steps, like, for example, the steps of the DOA analysis for each one. So, yung next lesson natin, yung next nating designs are mostly, ito yung mga more complicated, more advanced, na medyo in your life, I'm not sure if you're gonna see them in action or in paper. So maybe this is the only time you're gonna hear some of them. But I think it's good idea it's good thing to have at least know them. Okay, at least the overview. For example, in the future, you got your master, PhD. So mostly kasi yung mga designs ng ganito, sa mga advanced studies ginagawa. Especially if you're into engineering or scientist ka, chemist, ayan. So we will now discuss those more advanced designs. So let me share my Ayan, so yan. So medyo ano to I designed this presentation na hindi siya ganun ka overwhelming. Actually, it's more of overview. Ayan, kung kailan sila ginagamit na situation. Sige, ayan. So can everybody see my screen? Ayan, so we are on the module 4, other experimental designs. So for this module, we're gonna discuss fractional factorial design. So this is fractional factorial. So from factorial, so may basis siya from the factorial design. And then Latin square designs. So ito yung for factors that have same number of factor levels. So square siya. Ayan. So we have some variants of it, the Greco-Latin square and the hyper-Greco-Latin square. And then Plackett-Burman. Yan, this is also related to the factorial design, but there is just some variation or modification. And then lastly, the 3-level full factorial. So what you discussed kanina sa factorial is mostly the 2-level. Ayan. So 2 to the 3, 2 to the 2. Ayan, most of those na discuss kanina ay may mga either 8 runs or mga power of 2 runs. So 2 to the 3, that's 8 runs. 2 to the 2 is 4. Now if you have 2 to the 5, that's 32 runs. So dito sa 3-level full factorial, this is the 3 to the k. Ayan. So we will have an overview for each one of these experimental designs. So first, the fractional factorial design. So yan, like I mentioned kanina, siya, 2 to the k yung diniscuss kanina, diba? And most of the times, if you have, let's say, 5 factors, okay, that's 2 to the 5, that's 32. 32 runs. So combinations of all the treatments, so 32 combinations, that's gonna be a very big experiment, a long experiment. It's gonna take resources and it's gonna take time. So the fractional factorial is designed to address that issue. So with this, we will be able to only experiment on the fraction of the total runs that is obtained from the factorial design. So yes, so we just use a fraction of the factorial design. Ayan, ang question dito is, alin yung pipiliin nating runs? Out of, let's say we have 2 to the 5, that's 32 runs. So for example, we decide na the fraction we set is 1/2. So 1/2 of 32 is 16. So instead of 32 runs, we will have 16 runs. Now, if we have 140 pounds, so now the question, those 8 or those 16. So ano yan, for them, you have to take into account the interactions and the, yung software, like Design Expert or Minitab. So, yan. But, yun, you just have idea na, kung ilan yung runs na, i-run mo sa experiment. Ayan. So, yun nga, may various methods to do that. So, parang medyo na may pagka-mathematical yan. So, medyo madugo yan, but good thing we have software to do that. So, yan. So, again, just if one thing that you need to remember for fractional runs, yan, lang siya, you have fewer runs compared to the factorial design. Now, for Latin square designs, so medyo, this one is, Latin square. So like what I mentioned kanina, siya, if for example, you have 2 factors.
Kalipat na.
Let's say just 1 factor, and yung pinaka-function kasi ng Latin square designs is to deal with nuisance variables or nuisance factors. So you will have blocking here. If you remember the discussion kanina, diba, that we have the randomized complete block designs. So sa Latin square, we're gonna use the nuisance factors as blocks, as blocking. And ang isang requirement doon is that sa nuisance factors, dapat equal yung levels nila. So mamayang bibigyan ko na example kasi medyo abstract. So para mas maintindihan nyo at makita nyo siya sa picture. So may variant to, the Greco-Latin square and hyper-Greco-Latin square designs. Ayan. So yan, like I said, single factor lang yung interest natin dito. And we call that the treatment factor. And yung gusto natin i-control ay yung nuisance factors. Ayan. So ito yung so for Latin square, may 2 nuisance factors. Okay, for Greco-Latin square, we have 3 nuisance factors. And lastly, the Hyper-Greco-Latin square, we have 4 nuisance factors. So ano yan, may Mga letters yan. Latin letters, Greek letters. Ayan. So again, this one is used to control for nuisance factors. Kasi minsan may mga factors that affects our affects our expert. Gusto natin i-take into account yung nila, yung effect nila dun sa response variable natin or dun sa single factor of interest natin. Ayan. Ano yung advantages ng Latin square design? Yes. Factors. Just like sa ayan. And number 2, relatively small. Ayan. So medyo mas matipid to. And actually, isa ito sa preferred design. Medyo limited yung resource. So, compared with some preferred design. And so, mas yan, yung yun, ayan. So, the blocking like operators or it can be equipment. So, dapat and can you respond if audible ako? I think I was disconnected. Ayan, sorry. Sige, let me share my screen again. Marami ba ako?
Hello, everyone. We're just having some internet connection difficulties. Let's just wait for Sir Jerby to reconnect. Thank you.
Check mic test. Can everyone hear me? I think, yeah. I just joined again. Apologies. Can you respond if I'm audible? I think we had connection issues here at the office. So,
Can you?
can everyone hear me? Ayan, okay na ulit. Ayan. Nawawala-wala po yung internet namin. Ayan, again, mic test. Okay na po ba? Sige, let's resume. Saan ako nawala? Saan po yung last nyo na nakinig? Latin square designs. Okay po ba dito? Sige, let's just resume on the spot. Ayan, Latin square design. So, yan. So, yung first one na disadvantage is that, yun nga, kailangan equal number of levels for the blocking blocking variable. So, yun. Isang restriction yun. So, you need to make that sure na equal sila. And also, the Latin square model assumes that there are no interactions between the blocking variables or between the treatment variable and the blocking variable. So, compared with factorial design, na isa sa emphasis is the interaction effect. Diba? Kasi doon, we want to see kung pag sa high value ba ng isang variable or factor, and dun sa lower value, nagkakaiba ba sila? Ay, may interaction ba yung two factors? So dito sa Latin square, hindi natin interest yun. So the assumption is that there are no interactions between the blocking variables and between the treatment variable. Ayan. So equivalent ito sa specific fractional factorial designs. Ayan. So yung 4x4 Latin square is equivalent to 4 to the 3 to the 1 fractional factorial design. So ayan. So subset din siya. Ayan. Pero dito, specifically, hindi mo ina-investigate yung interaction effect. So example ng ito example ng Latin square design. So medyo so ito na yung table ng data mo, and then dito na din yung ating nuisance variables. Ayan, the operators and batches of raw materials. Sige, let's read the problem. So suppose that an study formulations of burning rate. Gusto natin laman yung effect sa burning rate. So each formulation is mixed from a batch of raw material that is only large enough for 5 formulations to be tested. So furthermore, the formula operators, and there may be skills. So naging hindi sila pare-pareho ng skills. And so nuisance yun, and check. I think we are having an issue. Test. Okay, I think I'm back. I think I will not, I will have to turn off my camera kasi medyo nagkaka-issue yata sa connection. So, sige, let's resume. I hope everyone can hear me now. I'll just turn off my camera so that it will not take up the bandwidth. Sige.
Sounds
Okay.
better po.
Ayan, let's continue. Internet problem. Ayan, sige, let's continue. I hope kayo okay yung internet nyo sa bahay. Dito medyo, ayan, hindi po nakikisama. Ayan, sige po. For this one, again, sige. Ayun. So mayroon tayong 5 operators and yun, may differences sila. So it's kasi yun nga, pwedeng merong mas magaling o mag-operate, pwedeng merong sobrang nangangapa pa. So we so in this Latin for this time. And we sense, so that's the first column here, batches of raw material. Kasi may differences din yung raw materials depending sa pagkagawa. Kasi hindi sila sabay-sabay pinroduce. So there could be differences.
Hello, everyone. We're asking your patience as we try to solve this connection issue. Thank you.
Mic test. Can you hear me? Am I audible? Mic test.
Yes, we can hear you po.
Ayan. I'm back. Ayan, sige, let's continue. So please go back to yan. And please show the problem. Ayan, thank you. Ayan, so ito na yung table natin. And ito na din yung mismong for template when we gather the data. So, and dito sa table, ito na mismo yung data natin. So as we can see, we have letter the table. So the left, yan, yun yung treatment. So which is, yun yung formulations. A is the first formulation. As you can see, the first one is A24. And you can see in the second column, we have A equals 30. So yun yung sa raw material 5 and operator 2. We also have for A, raw material 1 and operator 1. So as you can see, lahat ng operator and lahat ng batches will have exactly one instance of the formulation. So, yun. So, yan. That's why we have the Latin letters inside. Okay? So, tigigisang letter per column. At the same time, tigigisang letter per row. Ayan. So, that's the Latin square design. Sige, bilisin na lang natin. Next slide, please. Yan. Now, for the Greco-Latin square design, aside from just having the letter inside the table, meron ka pang subscript, which is the Greek letter. So, ito na yung pangatlong nuisance variable natin. So, meron tayong row nuisance variable. We have the column nuisance variable or factor. And then we have the Greek letters. So, we have 4 Greek letters na nuisance variables. Ayan. So, this is the Greco-Latin square design. Okay, next slide. Next slide, please. Ayan. So, next is the Plackett-Borman. So, ayan. So, for this one, it's the main purpose of the Plackett-Borman is for screening kapag yung interest. So, and dito yung pinaka-noticeable aspect nito is for power of 4. Di ba sa factorial design, we have 2 to the 2, 2 to the 3, 8 runs, 16 runs, and so on. Dito sa Plackett-Borman, we have more. Ayan, okay na po sige, konti na lang naman na to. Sige. This is a Plakat Burman. So we have multiples of 4 runs for this one. Ayan. So yun lang yung pinagkaiba niya sa although this one, we have, sometimes we just have a subset and multiple of 4 runs. Okay, next slide. So that's a Plakat Burman. I will give a resource material mamaya and you can check there. It's an online book na may details dito. And this is the last one, the 3-level full factorial. So ano lang to? Yung sa kanina factorial, pero we have 2 levels lang, di ba? The high and low. So dito, 3 levels. So medyo kung malaki na yung 2 to the 5 na runs, imagine 3 to the k. So yan. So we can combine this with a fractional factorial design para mas maging manageable. So dito, instead of high and low, we have low, intermediate, and high. So tatlo. Or 0, 1, 2. Ayan. Yung coding. Yung 0, 1, 2, di ba yung sa factorial usually negative 1, 0, 1. That's because yung 0 is a level factorial. We want to differentiate. That's why we have 0, 1, 2 for the coding. So yun, isa sa mga motivations why we have the 3-level factorial is that yun, we want to possibly address curvature in the response function. And that's we can do that if we have 3 levels ng factor natin. So we can also investigate quadratic relationships na hindi natin kayang gawin kapag 2 lang yung levels. Ayan. So ayan, I think yun lang naman. So we have the 4 fractional factorial designs, Latin squares, Plakat-Burman, and then the 3-level
the person assessing the opportunity cost and your desired outcome, which is what we call the benefits. So your benefits versus your
Okay, next slide. Yung last natin. So yung resources, if you are yan. So you can use the book. This is the reference book in school, in college. And you can also go to the site. This is online book as well. The discussions and experimental design. So you will see there the other details, or kung gusto nyo talagang aralin yung mga designs, you can go to this website, onlight.stat.psu.edu, stat 503, and you can see the materials there. So yeah, I think that's the last slide for my presentation. So I hope medyo na-familiar kayo sa mga more advanced experimental designs. So you can just look up then kung curious kayo for that. And yun, may questions po ba? Sorry, medyo na-rush. We've been stalled because of the internet issue. So, ayan, my questions. Ayan. Thank you with us for bearing with the internet issue. Kung walang questions, I can turn you over to Miss Jane for the next module.
Hi again. Thank you so much for still being with us. We will finish this. Yeah, so we're actually reaching the last parts now of this session. And for regression analysis, parang halos lahat naman ng diniscuss natin during the whole session is complex talaga. But regression analysis is also a whole, like, may mga college courses or subjects talaga na dedicated for regression analysis. It's ganun siya kalaki na topic. But for the sake of this SP 602, we will discuss the linear regression. But I'll give you an overview on what regression is. I'll try to I'll try to deliver this as quickly as I can, but I'll also try not to, skip parts or do parts without having been able to discuss them, like, especially the very important ones. So although I'll have to make a decision along the way, maybe I'll skip a very few I'll skip very few parts. But if you're still curious, feel free to send in your chat and or question in the chat, and I'll try to answer that. So all right, we are doing regression. I know that you've heard this word now a lot in this session alone, and I think you've also heard this before coming into this session. So here our goal is just for you to understand regression, generate models, here linear models muna, and then interpret and use this to predict response variable. So here, we did in the context of experimental design, so we have results expressed quantitatively, and in terms of empirical models. Empirical, which means these are estimated, right, from the data that we have. And regression models are the basis for that. These are also used outside experimentation, like when you have historical data or you observe an uncontrolled environment, things like that. And here in many problems, you have two or more variables, and let's say they are associated, make correlation, but still you really want to know more about the relationship. What's the strength of their relationship? What's the direction of their relationship? How does one affect the other? And as an example, in a chemical process, the yield here is a product. The yield of the product is related to the operating temperature. So the chemical engineer may want to build a model relating yield to temperature and then use the model for prediction. Like if I set the temperature in a certain level, how much yield will I expect? Is it going to be acceptable in terms of, the profitability, if this is a business, the profitability of the manufacturing process, or they can optimize the process to say they can see na if let's say the temperature is at let's say 100 degrees Celsius, they get the maximum yield. Pero kasi initially isipin mo baka pag tinaasan mo pa kaya pa itaasan din yung yield, but then hindi pala kasi bababa na siya. Let's say quadratic yung model mo, so bababa na siya, hindi na optimal. Nataasan mo yung temperature, gumastos ka to increase the temperature, but then bumaba yung yield mo. So you can use this for process optimization or process control. And in general, there is a single dependent, and then a number of independent variables, or we sometimes call this regressor variables. So yung mga x sub 1 up to x sub k, kunyari if you have k regressors, and then you have y as your single dependent variable. But there are cases when you have multiple independent variables. And then you want to see the relationship between these variables, and you want to characterize, you want to do that by using a regression model. And this word actually came from regressus, which means to go back, no? Saan ba nanggaling to? And it means, ganun lang, babalik lang siya, ano yung previous state niya. In psychotherapy, psychotherapeutic method whereby healing is facilitated, inducing the patient to act out a behavior typical of an earlier developmental stage. Or in medicine, diminishing of a cellular mass like a tumor or an organ. And then in programming, kailan mag-reappear yung bug in a software na dati nang na-fix. In statistics, we use regressionist, a specific method talaga siya. So we have your data, and then you have two or more variables, and then you want to estimate one of those variables based on the values of the other variables, your regressors. And in analytic method, it's an analytic method to measure association then of one or more independent variables with a dependent variables. Like if you want to measure their relationship, no, kaya meron ka tatlong regressors, x1, x2, x3. What together, silang tatlo, ano yung relationship nila doon kay y? Kasi pwede namang x and then relationship ni y, diba? Dalawa lang sila. But you can use regression models as well to check ano yung magiging relationship kapag sabay-sabay yung tatlo. And in regression analysis, here talaga we have steps or processes. So actually, it's gonna be easier for you, no, if you want to do regression, you can. Sobrang dami ng resources ngayon available online, so you can check what's the process and follow along. And so relationship talaga yung inaaral natin sa regression. And yung dependent, alam niyo naman na to, ito yung a response or ito yung outcome. Madalas, we name the dependent variable y, then independent variable, tinatawag pa din silang tawaging regressors, predictors, covariates, or features. Ayan. One of the most common talaga is linear regression, which means na yung variables mo, yung relationship nila follow a line, a straight line. And dito, yan. For example, the method of ordinary least squares, OLS, it computes the unique line in the hyperplane, or depende. Kung two variables lang, unique line, that minimizes the sum of squares of distances of the true data of line or the hyperplane. Kasi kung itong red na to, kung medyo i-tilt ko siya ng paganon, eto dito, iakyat ko yan dyan. Suppose ganito, dito nandito yung line. Yung difference ng bawat point, yung layo nila from that other line is gonna be larger. Yung i-total mo yung square ng differences nun will be larger than another line. So, maraming possible lines ka na magagawa to indicate this relationship, but you want to find that one line which will give you the smallest sum of least squares ng distances ng data points mo. And here, suppose you are a sales manager trying to predict the next month's sale figures, and you have several factors to consider, whether competitor, their promotion, and the new rumor of a new and improved model. So you have to consider these. Now, in regression analysis, it's a mathematical way, of sorting out these factors. And you want to find out which ones impact monthly sales. And it will answer any or all of these questions. So which factors matter most? Which can we ignore? How do these factors interact with each other? How certain are we about all of these factors? So maganda tong regression, kasi regression analysis, kasi hindi limited yung use niya sa experiments, where we just learned experimental design in the last 2 days, and whatever you're gonna learn here, hindi siya limited doon. But for sure, of course, there's the application. And why do we do regression? Like, why do we have to go through all the trouble computing all of the mga mean squares, sum of squares in between, all of those things? One, prediction is part of statistical inference. One particular approach to such inference is known a predictive inference. Ang daming fino-forecast, actually. For example, the Philippine government will forecast the inflation rate. And based on that forecast, decision makers are gonna, meet together, decide on strategies. Kasi kunyari, yung forecasted na inflation rate is super high. It's gonna make the whole country suffer. Decision makers will have to do something before we get to that point. So it helps them make decisions, strategize, and you know, it's a whole country, like how we're more than 100 million Filipinos at stake. So using regression, or maybe they're using other techniques, but it should be similar to this. But prediction is a really important part in our society, practically speaking. And ayan, so forecasting, ito naman making predictions. Kanina, predictive inference. So, and then ngayon, forecasting. And ito naman yung mismong pag-make ng prediction. So they are actually tied together. They're tied together. Kasi syempre, if you have a predictive model, that's one thing. You build your predictive model and you test that, and now you use that to forecast. And yeah, this is based on past and present data. And another is to infer causal relationships. I said this in the beginning of this course. Association does not imply causation. Just because two things are related doesn't mean that one causes the other. And regression models will help us see if one of the many variables in context is, affecting the other. So we have two types of regression models now. So we have, actually, no, these are our types of regression models. We have these two types of models, deterministic and probabilistic. Deterministic, ano siya, certain ka in all aspects. And meanwhile, probabilistic, you have to account for error. So let's see. Ayan. So for example here, if you can recall, no, yung mga models natin previously, yung mga process models natin, merong experimental error na term. And those are examples of probabilistic models. Meanwhile, the deterministic models, ayan, BMI, ayan, sure ka talaga what the outcome, sure ka what the BMI will be given like specific weight and height, right? So regression models is actually under probabilistic models, as I mentioned. So probabilistic models, meron kang regression, correlation, and you have other models. And this regression model, if you have only one explanatory variable, then you can use a simple regression model. Otherwise, you have multiple regression models, but you still can use linear regression models or multiple linear regression models. Depende siya on how many variables you have. And here, this is one of the linear regression model. It's one of the widely used modeling techniques. And you have to take note, the dependent variable is continuous here. And then the independent variable can be continuous or discrete. And the nature of regression here is linear. So you have to check, plot ka ulit, tingnan mo, may linear relationship ba? If hindi linear yung ano niyan, yung plot niyan, if it does, kunyari, it looks like a parabola, then I want you to stop and wag mag-pursue ng linear regression model agad-agad. You can either transform your data, do the technique before you proceed to linear regression. But here, for this example, you can see the data points, yung mga purple na dots, they seem to follow a line. Parang may line sa pattern nila. And then, the linear regression model will establish the relationship now between a dependent variable and one or more, as I mentioned. Isang response variable, one or more regressors. And using the best fit straight line or the regression line, we will know the relationship. Aside from knowing that, for example, the regressors impact Y, we will also be able to determine the effect, like the magnitude of their effect on Y. Now, this is the famous linear regression model. We have Y sub I, it's equal to beta sub 0 plus beta sub 1 multiplied to X sub I plus epsilon I. So this is the random error component. And here, if X is 0, then this is going to be beta sub 0 is the intercept, no? And these are the linear components. Ito yung slope coefficient. And of course, your independent variable or your regressor. So dito, sa model na to, it's a simple linear regression. So kung meron ka pa, kung meron ka pang another dito, kunyari plus beta 3, beta sub 2 times R sub I, capital R sub I. So that's going to be a multiple linear regression. Questions at this point? All right. So beta sub 0 and beta sub 1 are called the model parameters. Sila yung ine-estimate natin when we say we fit the model. And then of course epsilon it just accounts for the variability, no? Kasi nga probabilistic yung model natin. Hindi siya deterministic. Ayan, sabi niya, if error andito yan. So if the error is not present, then it's a deterministic model. And here, an equation that describes how the expected value of Y as its own mean or expected value, ayan. Ito yung E na yan, that's expected value of Y. It's equal to beta sub 0 plus beta sub 1 X. Ngayon, nawala na yung epsilon kasi we are actually expecting that the errors are normally distributed, and kapag normally distributed, the mean is 0. Kaya mawawala siya when you take the mean of the function. So here, E of Y, that's the expected value of Y. And then we have here the beta sub 0, your Y-intercept, and the slope. Yan. If, alam mo na, diba, yung beta sub 0 and beta sub 1, if you already know them, then we use this equation instead. Kasi alam mo na for sure eh. But in practice talaga, when you are sampling, when you are experimenting, you don't have the data for the whole population. You only have a sample. So what we can do is we can only estimate beta sub 0 and beta sub 1. And we denote that by B sub 0 and B sub 1. Kapag parameter estimates, no, if it's a characteristic of the population, we usually denote them by Greek letters. And then kapag estimates naman from the sample, we usually denote them by the English letters. Yan. And how are these two related, these two sets of coefficients? When you fit, when you use the B sub 0 and B sub 1 in your model, you are getting the kasi kunyari hindi mo makukuha yung exact true value talaga, no? But you are getting your best estimate to the truth. So that's how I would like to put it. You're estimating the truth with the data, with the information that you have. And that's still better than having no idea of what's happening. Yeah. So eto, you have your model, you have your linear regression equation. This is and then you will have your sample data, and from your sample data, you estimate your B sub 0 and B sub 1, And when you get them, actually, you will have to test that B sub 1 is not 0. Mag-hypothesis testing ka dyan. And if it is significant, then your model, the model that you built should be valid, no? So B sub 0 and B sub 1 will provide good estimates, reliable estimates to the population parameters beta sub 0 and beta sub 1. May questions ba? Okay, wala pa so far. Ayan. So, for example, you have this data and you want to derive the estimated linear regression equation. So, estimated linear regression equation, it's the linear regression model. And here in this example, Excel was used. So first, again, you first plot your data, and it looks like your data points follow a straight line. So we can proceed. And you know now already how to set up your analysis tool pack for Excel, right? So I'm going to skip that. So what do? So you click on data analysis, and then you choose regression, and then you select the Y range. So in this case, the Y range is this one, and then this is going to be the X range. So input the X range. If you include yung weight cell or yung height cell, then of course you tick the labels. And then confidence interval, you can actually tick this one if you want the results to produce the confidence interval. And also the residuals. You have a lot of options here. You can, if you know, you can explore these features. And then after that, you click the OK button. Yes, still 5 lang tayo. We have 3 minutes now. I'm just gonna try to make this really fast. Good thing. You know now already how to interpret, how to read these results, right? So dito, the p-value is really, really small. That means there is a you would like to extend until you're able to finish all that. You would extend until, okay, that's Monica. Thanks, Monica. All right, and so here the regression is actually significant. And to get the model, we look at this part here. So the intercept is at negative 316. And then the height, this is the coefficient for the height, 6.97 approximately. And then you see you have here your, confidence intervals based on 95% confidence level. And you check the p-values here are also significant. So our model is actually good. Oops. Okay, and so there are goodness of fit measures now. You have your model, and then you still have to check na your models are actually, this is the right model for your data. So you have multiple R. This correlation coefficient will tell you how strong the linear relationship is. For example, dito, multiple R is 0.94 approximately. This is positive. That means the relationship is positive. X affects Y positively. Nag-i-increase yung value ni Y as the value of X increases. And this is very close to 1, which means that the relationship is really strong. And kapag naman negative, we have a negative relationship, tataas yung value ni X, bababa yung value ni Y. But when they're close to 1 or negative 1, that means the relationship is strong. Kapag naman close to 0, weak. And pag 0, no relationship. I mean, hindi no relationship, no linear relationship. Because here, we're doing linear regression models. So, possible yan na may relationship naman talaga, pero 0 yung makukuha mo dito. But that's just because mali yung model na ginamit mo. And then, of course, you still have your R-square for the model fitting, R-square adjusted, and standard error, and you have 10 observations. And what else do we have here? So yun. The standard error, it gives you the precision of your regression coefficient. And the adjusted R-square, I've discussed this a bit kanina. But R-squared tells how many points fall on the regression line. The degrees of freedom here is n-1. So if you have 10 points, you have 10 data points, then -1, that's 9. And the sum of squares, these are stands for sum of squares, MS stands for regression mean square, and then you have this is the mean square, and then the F test is done actually by computing I cannot recall now, but it's actually done. You can get the 57.42 by computing from any of this. Wait lang. Yeah, apologies for that. But yes, it just makes it easier for you because it's already given, no? And we're no longer discussing the formulas, but we hope that this gives you, the knowledge already how to interpret your Excel results. And the formulas, even if it's present, we don't really compute for it manually anymore. Thanks to the softwares. And here, ayan, R-squared, it's actually the variance explained by the model divided by the total variance ng data mo. That's how you can think of it in another way. And yeah. Okay. Here, so we have here the estimated linear regression equation. It's y is equal to 6.9681x minus 316.86 kasi negative yung nakuha natin kanina na y-intercept. And ayan, this is the end for simple linear regression. We wish to be able to discuss sana more pa of linear regression, but again, we're time constrained. So where do we get the regression coefficient? Question answered by the slide. Oh yeah. So thank you. Yeah, I know it's already 3 minutes past 5, but I would like to take 2 minutes to see if you have any questions. For me and Sir Jerby, actually, if you have any questions for any of us. Okay, it looks, ayan. Are least squares analogous to residuals? Okay. So, sorry, Sir JB, parang nag-echo. Okay. So, yung least squares yung squares actually ng residuals. So, they are related. So, sa least squares, you take the, sa least squares method, you take the residuals and then you square them and then you add them. Kasi diba, dito, marami kang lines na pwedeng i-fit dito eh. Pwede ding paganyan yung line mo, pwedeng paganito yung line mo, pwedeng paganyan yung line mo. Maraming lines na pwede mong i-fit sa data. Pero, when you use the least squares method, eto yung line na magbibigay sa'yo ng pinakamaliit na squares, na sum ng squares ng residuals. Yun. Kasi marami kang line na pwede i-fit eh. So, alin doon yung gagamitin mo, diba? And it doesn't make sense kapag ganito. For example, yung medyo, talaga, reach na talaga yan. Yan. Thank you, Paul, for your question. Ayan. It's already 5:05. So, I think I will end here. Thank you very much for your attention and for participating. Wishing you all the best in the analytics field. SSR, someone ng scared residuals. Yes, thank you so much.
All right. Thank you very much, Miss Jane and Sir Jerby, for an in-depth discussion on experimentation. So before we end our session for SP 602, you guys know the drill. Please turn on your cameras as we have our photo op with our SMEs. EJ, on your cue, please.
Hi, good afternoon, everyone. So we have three pages po. On three. First page. 1, 2, 3, smile. Next page. 1, 2, 3, smile. And last page. 1, 2, 3, smile. Yan. Thank you, Miss Monica. Back to you po.
Thank you, everyone. Thank you for also staying with us, Spartans. So the link to the course satisfaction survey is now available in the chat box and on your screens. The passing mark for the assessment is 3 out of 5. The form will be open until Monday, September 11th at 11:59 p.m. Completion certificates for those who passed will be available at the Sparta portal on September 19, 2023. For other inquiries or concerns, kindly email the learning support team, or you can also join our Facebook group to engage with fellow Spartans. Thank you for joining our 2-day live course session for SP 602, Experimental Design and Analysis on behalf of Project Sparta. This has been Monica Reyes, your host for today. Stay safe, everyone. And maraming salamat. Ingat!